Hello, my name is Bob Norman. This is part 2 in a 3-part discussion on how to use Labview. It's directed towards electrical engineers and people with a control background. As I pointed out in part 1, I have a 45-day evaluation package, and I'm just trying to capture what I've learned for myself and others that may download the evaluation software. So in this part, we're going to discuss how to take a complicated motor model that we covered in part 1 and convert it to what's called a sub-VI. So instead of having all this information here, all these discrete little blocks all over the front panel, I want to condense it down to a smaller block that looks something kind of like one of our integrators. In order to do that, what we do is select the devices of interest, and we'll do that as such. Here we're going to leave some of the controls around the perimeter and the charts on the right hand side so that we can compare to what we did before. So there's our selected devices. Let me pick this and see if it takes the name Omega when I create it. So we are going to create a sub-VI, and it automatically does it as such, and you can get information about it. As you can see, in one case it picked up the name initialized and DCV in, no problem, but the other ones really don't make sense, so I'd like to change those. Let's go ahead and clean up this block diagram first. So what I want to do is take this and just slide it up a little bit, and then we'll push into here, and you can do so by double clicking. That brings up the front panel. Control E will bring up the block diagram. And let's go ahead and make edits to this one. Here, I just want to view, I don't want to view these as icons. They get kind of big and clumsy. I mentioned that this one here took a name L. Probably found L down here and for some reason used that one. But let's go ahead and take this control and the wires, and we'll slide them up to keep it somewhat clean. And then let's change the properties on this, and we'll call this initial condition. And I want to change this to have something that makes sense when we use our help. So I'm going to change this to Omega and this to Theta. Excuse me, I got those reversed. There we go. I could call them position and velocity, but we'll leave it as such for now. And then let's go back to the control panel, and you can see that these names have changed now. Now let's say we want to add a pin. How would we modify this block? Well, the way we do that is, let's change this into a control. So if I click on this, change it to a control, it's going to take the value of TL, which I like. We'll get rid of this label now because it's pretty obvious that it's TL. And then we go to the front panel, and what I'm going to do is click on a pin and associate it with TL, and you see that this color changed, and our context help has changed as well. So now that's input to the system. Just clean this up a little bit. I prefer to have this lined up. As such, this is actually an input, so let's move this down here. Decorations, let's go ahead and just put a box around the inputs. I find it useful to kind of group some of these things together so it looks a little bit more obvious, and we could add text and whatnot as well. There we go. Let's save this. I created this one earlier, but that's okay. We'll just write over the top of it. Yes. We should be able to close it now. And let's take a look at the context help here. Okay, it's showing our input. I think we should wire off the load now to a value of 0. So let's go ahead and click on this, create constant for now. Let's put a label on it so we remember what it is, TL. And let's go ahead and run our simulations again and verify that it's doing what we expect. Hit the wrong button, TL. We'll go to the front panel and let's go ahead and initialize, run, get this ready. There we go, and as you can see, once again, it's approaching a value of 1, and it's integrating at the same rate of 0.1 radians per second. So we've successfully wrapped everything in a box called a subview, and that concludes this part of the presentation. The next part, we're going to do some control loops around our motor and see if we can get it to approach its final value quicker. Here you can see it takes a good couple seconds to get there.